Hello, everyone. Welcome to the Engineering Bard Show. Yes, another. This time's going to be a little bit different. We did some music. Now we're going back to the engineering. So today we're going to talk about is the embedded and the ARM system. So what is the embedded system? We're going to talk about that. Are the embedded systems part of AI? And the answer is yes, they are part of AI. What are the three main embedded systems? The basics of the embedded system and the history of the embedded system. So what is an embedded system? So embedded systems pretty much everywhere. Everywhere you see these days, there's an embedded system. It's in your cars, in your coffee makers, your dishwasher, planes, robots, everything that when it comes with some sort of electronics, there is some sort of device that controls it. And so what does a common embedded system? Well, the first one there is the Raspberry Pi. That's a pretty common one. It's different. It's not necessarily it's embedded. It means that you can put that inside a system. It's not a real-time system, but that one has its own software or operating system, and they use a Linux-based operating system. There's other types that are like that, but this is a generally type of that one. There's also the Arduino Uno, which is a very common, very popular, very simple to use. It's similar to what we're going to talk about, but it's not exact what we're going to talk about. And what we're going to talk about is the embedded, the Nucleo 7476RG. This is what we're going to talk about throughout this experience. So hope you guys will enjoy that. And that is the true embedded system, but they're all embedded. So when we talk about the embedded systems, we do have several things to consider. There's an input, there's the software, and then there's the output, and then there's time to create it. So this is pretty much, you're always going to be thinking about input, you're always going to be thinking about output, and you're always going to be thinking about time. So that's something that is, to consider. So the history of the microcontroller, in the 70s, the embedded systems was used by digital and analog systems, meaning they use chips. They use AND gates, OR gates. They use flip-flops. All this stuff was pretty, they were fragmented. They would use BJT transistors, and they would put together very complexly to create a system. Soon, the problem with that was it wasn't reprogrammable. Once you created that system, you had to redo the hardware all over again. So by 1981, a British broadcasting system, they came up with some projects. Anyone to come up with some reprogrammable controller. So there was mostly Apple, IBM was up for the challenge, but there was a company down Acorn who did it. But the problem was, even back then, and not till pretty recently in the 2000s, they were pretty difficult to program. And so this course is going to be more simplified, and it's going to be so even a guy like me can program an embedded system. So it doesn't take a guy with a PhD who's in electrical engineering to basically learn how. It takes a guy who's willing to work hard and just understand some basic concepts. Now, the concepts do, like many other concepts, they do get more complicated as it progresses. So history was the Acorn redesigned a 16-bit processor, and the engineering scientists took it and they said, well, this has some complex features like graphics and computer registers that was meant for the computer systems back in the 80s. And so they decided to redesign it, and they called it a complex instruction set for computer. And they said, let's go ahead and change that. So Acorn Computers redesigned the processor, And so they call it a reduced instruction set computer. And by 1990, they changed their name to Advanced RISC, which is Reduced Machines Limited. And that became ARM. And ARM is what the process that we're going to be using for this system here. And on the next video, we're going to get into a little bit more complicated detail. We're going to strictly go into the Nucleo L476RG, and we're going to start analyzing that completely. But this is just an introduction. So thank you. Please subscribe for more cool content, and I look forward for some more videos. Thank you. Bye. All right.